Hello, parents. If you're like audiences everywhere, I train teachers all over the country. And if you're like audiences everywhere, you have the traditional perspectives concerning mathematics education. What are the traditional perspectives? Well, you know, math is hard. Math is hard to teach, math is hard to learn. Isn't that what you've basically, after 12 years of public school education, haven't we learned more about what we cannot learn than what we can learn? I can't do math, I can't do science. It's just amazing. We basically learn more about what we cannot do than what we can. And we're going to dispel that tonight. And when I say dispel that notion, I mean I want you to see in very concrete terms what it means when I say that every one of us is gifted for the learning of mathematics. I want that to be palpable. I can say that, and you can choose to accept that because you yield to my authority, I suppose. But I don't want you to accept it that way. I want to see the basis for making the statement so you understand clearly what I'm talking about. So for the first part of this, I'm going to talk about the philosophy behind the mathematics program. And I know that based on my experience, I'll be able to make that very clear to you. I urge you to ask questions. Don't be afraid to raise your hand and ask questions. You'll only help me to make the presentation better. Along the way this evening, I intend for you to see, to catch the vision. There is a vision here. And it's important that you catch the vision, that every one of your children can be a magnificent, a very competent learner of mathematics. And I want to make that very clear to you. So let me begin by looking at children when they are at home before going to school. Yes?
Excuse me, I don't mean to be rude, but I can't hear you.
Oh.
Somebody else talking again.
Oh, Bruce. Well, okay, I'll go over here. Thanks. Thank you for that. Can you hear me better now? Just a little bit? All right, I'll speak louder. Can you hear me now? All right. So I'm going to begin by looking at children as they are at home before going to school. In particular, I want to draw your attention to a child I shall name Johnny, who later becomes a special ed student in the public school system. Let's look at Johnny, the future special ed child, at home before he entered school. Do we find Johnny learning stories? That future special ed child, does he learn stories? Yes, there's something about a story that draws them into it, that engages their minds. So we see Johnny, the future special ed student, learning stories competently before going to school. And how many times does Johnny need to hear the story before he says, he claims ownership? He says, I know the story. How many times? Once, twice, 3 times? Suppose it was even 10 times. That's pretty fast, anyway, to learn a whole story. But you know it's not 10 times. More like twice, 3 times. And then he knows the story. Now, when you look at that, if he learns a story, that child learns a story after hearing it 3 times, that's pretty accelerated, isn't it? That's an example of accelerated learning, right? By Johnny before going to school. And then let us look at Johnny as he learns a story. Can you see his face? Does he look tense in the way you and I looked sort of tense when we were studying for that biology test when we were in college, you know? We were studying for that biology test at 12 o'clock at night. The test at 9 in the morning. Remember the tension we felt? Does Johnny look like that? Is he looking tense? No, he's relaxed, isn't he? See, so there's no tension in Johnny as he learns this story so rapidly, you see? So if there's no tension there, then perhaps we can begin to sense that there's some kind of natural learning going on. There's something rather natural going on, so natural that the vast majority of children in the world, virtually every child in the world, regardless of culture, learns stories rapidly after hearing them once or twice. Something kind of natural going on. There is no tension. Let's examine this, because I want you to put your fingers on that natural learner, that kind of early competence. Johnny learns a story, you agree? Has he memorized it? Has he memorized it? Do you remember what it was like to memorize a poem? Do you remember that you worked pretty hard on that? This is not something you got after reading it 3 times. I mean, to memorize a poem, you got to read it more than 3 times. You understand? And you all have done something like this, so you know that it requires effort, right? You work pretty hard to get it into your heads, don't you? Well then, did you see, Johnny, when you teach your children, when you read a story to your children, do you see them functioning like that? No, they're not memorizing anything. In fact, when they tell the story, are they using the original words? Or are they using their own? Aha. So the natural learner has made no effort to memorize anything. Are you with that? The natural learner has made no effort to memorize anything. And the proof, as I said, is when he tells a story, the words he uses are not the original words. Well then, if he hasn't received the words of the story, then what has he received? We need to look at that. It's not the words. So what has the child received when he or she hears a story? Well, they've received connections, how things connect and how they flow. Right? Isn't that what a child is watching as a story unfolds? They're watching how it's connecting and where it's going. Isn't that what's going on? You have a sense? Think of yourself as a youngster hearing a story. Weren't you watching where it was going? And here's a telltale sign that this is exactly what you were doing. Remember the times when you would begin to anticipate where the story is going? You jump ahead of the storyteller. Haven't you seen the same thing in your own child? You see? And what is it that makes a child jump ahead in the story? Isn't it the trend that he or she has perceived? After hearing this much of the story, they get a sense of where it's going. And they begin to jump ahead before you do. Right? So are we pretty clear on this, that what children get from stories is not the words, but the order of the events, that this is what they're watching? Is it pretty clear that this is what fascinates them? One way of saying it is how things connect and where they flow. But when things are connecting, you're building a structure. What children get from the story is its structure, that this happened first, and this happened next, and this happened third, and this happened fourth. And they're watching the structure of the story as it evolves. We're talking about a mental structure. This building is a physical structure. There was a time when it didn't look like this, and the pieces were put together, so they took this appearance, right? So this is a physical structure, but there are things called mental structures. When you piece things together in your mind, and you say, I see. Mental structures. The natural learner is intensely engaged with mental structures as a basis for knowing, right? And since virtually every child learns stories very comfortably and very easily, then it might be safe to assume that every one of us has a gift for perceiving structures, right? It's a part of you that made you see how things are connecting. So everyone has the gift, since all children learn stories, every one of us has the gift for perceiving structure. That is how things connect and how they flow. We have a gift for receiving structures. And we have a gift for retaining information based on structures. Three things. For perceiving structure, a gift for perceiving structure, receiving structure, and retaining information based on structures. Now I'm going to prove this to you. I'm going to do an experiment. I'm going to make you retain information. I'm going to show you how you retain information based on structures. I'm going to say 3 words. And I want you to watch your mind to see what your mind does with those 3 words. Right? You will see that your mind makes connections among the 3 words. Right? And although I gave you 3 words, you will be able to give a lot of other entities, other things connected to these 3. Are you ready? Woods, wolf, grandma. All right? So, did your mind connect those? Yes. And from the connections, could you perceive from the connections that there's a larger body of information which contains these 3 entities? And that these 3 pieces of information are contextually embedded in a larger whole, and the title of that whole is? Okay? It is the embryonic mathematician in every one of you that permits you to do that. Our God, the God we serve and the God we are blessed to know, is a designer. He designed our minds to perceive structure, to receive structure, and to retain information based on structures. He designed the natural learner in us. All right. So, I'm going to ask one of you, because I want to add more substance to the point I'm making, that is, that we all have the gift for perceiving structure, receiving structure, and retaining information based on structure. I'm going to ask for one of you to volunteer to start telling a story. And I'm not going to let you tell the whole story, but I want the rest of you to watch the face of the one who tells the story, watch the eyes, watch the expressions as they bring it back. It will be an example of retaining information based on structure. Because if I ask you to tell me a story that you've heard, that you've learned a long time ago, right? And if you can piece it together now, right, then you'll be useful to me at this point. Now, please, you don't have to demonstrate that you know the story well. In fact, the less well you know it, the better. So can I have a volunteer? I want to try. All right, now, I want you to, is it a story that you haven't looked at recently? Good, good. All right?
I guess.
A story that you haven't thought about recently.
Oh, haven't thought about recently.
Yeah, have not thought about recently. A story that you've heard a long time ago, and there's some, I want to bring it back. But if you told it recently, it wouldn't be a good idea.
Okay.
You got one?
I could tell a story, huh?
You got one?
Not yet. Whisper
All right.
one in my ear.
I don't, anyone else? Anyone, maybe someone else?
He's getting up. He's got a story.
You've got a story?
Oh, bummer.
Well, come on. Somebody who has just come, it's all right, it's all right. Come on up. She's going to try. You've been to them recently. All right,
Yes.
now, some story you haven't told for a long time. All right,
She's thinking. Good.
good. Look at her face. Can you see her face? All right, start. Once upon a time.
Once upon a time, there was an old woman who lived in a shoe. She had so many children, she didn't know what to do. So she gave them.
No, that's all right, that's all right. Keep going, keep going.
So So she gave them some broth without any bread, and she whipped them all soundly and sent them to bed.
Now, that's a rhyme. I want to tell me a story. It's a little rhyme. Tell me a story. Anyone?
Any stories? Came to America.
No, well, you see, I want to hear Cinderella or something like that. Who can tell me Cinderella?
I can tell you Cinderella.
Okay, go ahead. No, go ahead. Tell us Cinderella.
Once upon a time, there was a king and a queen, and they had a baby. And then, I don't know if the mother died in childbirth or died when she was a toddler, but she died, and then the king remarried, and he married a wicked, wicked woman. And she came with 2 children too. I think their names are Drusilla and what? Something.
Doesn't matter. Go ahead.
Drusilla and Priscilla.
No,
something
good,
like
good. Go ahead.
that. And what happened? Okay.
Stay with it, stay with it.
Okay. One day there was a ball in the city, and
All right.
town.
All right, that's good. Very good. Thank you. All right. What did you observe? What was she doing? I asked her to recall a story. Did she know the story from beginning to end before she started? No. So if she didn't know the story from beginning to end as she started, she was engaged in the attempt to recall the story. But she didn't know it from the beginning, or immediate from beginning to end. So what was she doing? She was reconnecting it. Every time she stopped, You see, remember when she said, What was she doing? Searching for something connected. And then that would come. Then, and then something connected. So you saw her in the act of using God's gift for retaining the content of that story. Right? She was engaged in the exercise of using God's gift for retaining the story. And what was the gift? She was restructuring it. And now if you're restructuring, you must have structured it originally. When did she structure it originally? A long time ago. Was she deliberately doing the structuring? No. She wasn't deliberately. She didn't set her mind on it. I'm going to structure my mind. As a child, you don't do that, right? So without even being aware of it, she was structured. Right? And in her effort to recall the story was an effort in restructuring what she originally structured as a child. Okay? That's God's gift. You see? And it is quite reliable. Every one of you, any one of you, if you were to tell the story of Cinderella or some other story, would do the same thing. But little by little, the whole thing would come back, not exactly the same, but you would do reasonably well. You see? And remember, now it's a long time ago that you heard the story. You follow me? So that you see, that was the gift in the act of retaining information based on structure. Because you saw her restructuring. I say to you, this is the gift for learning mathematics. All right? That's the same gift. And I'm going to make that very clear. So then can we assume, do you have a basis for the claim now that we all have a gift for perceiving structure? For receiving it, because that's what you get from a story. You receive the structure of it. That is this first, then that, then that. And a gift for retaining information based on structure, which what she was doing. Are you with me? Okay. Of all the academic disciplines, which is the one that studies structures for their own sake? Mathematics. Mathematics is the academic discipline that studies structures for their own sake. Huh? So now, I want you to see the connection, see if you see where I'm going. If we all have the gift for perceiving structures and receiving structures, and if mathematics studies structures, then at least at this point in my presentation, it appears that we all have the gift for, for learning mathematics. See? And now having said that, you should be quite alarmed. You should be saying, is this man in his right mind? You might be saying that because after all, if I claim that you all have the gift for learning mathematics, I need to fix something here, don't I? I better come good now, right? If I can tell you we have the gift for learning mathematics, then I better explain this. So let's look at that, because there is an explanation. Well, all of you have the experience of trying to write a letter or an article or a paper, right? And you have something in mind. To put it in other words, you have a structure in your mind, right? And what you're trying to do in writing is to convey the structure to the one who reads it. So the one who reads it will receive the same structure you have in your own mind. Have you ever had that experience? You don't have to be writing anything. You could also be speaking to someone. And you want to know how to say it so they receive the structure that is in your own mind. You've all had that experience, right? Well, what do you all notice every time you try to do that? Don't you notice how careful you have to be with your words, with your sentences? You have to say it right. And sometimes you might try to say it this way and say, no, that's not going to get it across, right? You try it another way until somehow some words come together and you say, yes, that'll do it. Are you with me? So what am I saying then? If you're engaged with the exercise of communicating a structure in your mind to the mind of another, you better be careful how you speak. You better be careful how you speak. If you speak it right, they'll get it. If not, they won't. Right? So you see, if you speak it right, then the gift is activated. This gift from God for receiving structures is activated based on how you speak. But it is deactivated if you speak the wrong way. So now, let us look at teachers. Look at how teachers speak in classrooms across this nation. Now, by God's grace, I've had the privilege of training teachers all over the country, so I know what I'm talking about. So let us look at long division. And let's see how teachers talk about long division. And what I want you to focus your mind on is this. While teachers are verbalizing long division, does my mind click with understanding in the same way that my mind clicks with understanding when I hear a story? That's what I want you to evaluate. So let us go to the board now, and we're going to look at long division as taught traditionally. Can everybody see this? Can you see this at the back? So, what do teachers say? Now, in my past, I taught 4 years in junior high school many years ago. I taught 4 years senior high school. Then I taught college for 25 years. So I'm going to talk long division the way I did when I taught junior high school when I was a young man. But that way of talking through long division is the way teachers all over the country talk right now. Sounds like this. 4 into 2 you can't. Well now, is that true or false? Only last week, the teacher might have been dealing with place value. And in a place value lesson, if a child called that 2, the teacher usually gets quite upset. They would say, don't you see? This is a thousands place. How can you call it 2? It's 2,000. And if you were like me as a young teacher, I was a very emotional teacher, I would have said something like this: have you left your brains at home? Don't you see? This is the thousands place. Don't ever call it 2 again. That was last week. This week, I'm the same person. And you don't change much in a week. And I say to kids with all the authority invested in me, girls and boys, 4 into 2. You can't. Well, you see, it can't be both 2 and 2,000. You know there's a huge difference between $2 and $2,000. So these are two different numbers, aren't they? You see? So this is inconsistent, isn't it? And of all the academic disciplines, which is the least tolerant of inconsistencies? Mathematics. Okay? So no math teacher, you violate the spirit of mathematics when you talk like that. You see, mathematics is about truths. You know, you have to speak truth. You know, it's a system of true statements called theorems. You see, these theorems are true statements. So then, to call this 2 is false. And then I say 4 into 2, you can't. That's not true. There are lots of 4s that can go into 2,000. So the teacher who speaks this starts off with 2 falsehoods. By calling it 2, that's a falsehood. And the other falsehood is that you can't. And it gets worse. It says 4 into 25 is 6. It's not 6, it's 600. Because this is a hundreds column, right? And then it says 4 times 6 is 24. But that's not 24, it's 2,400. That's the truth. And then they subtract, you call it 1. It's not 1, it's 100. Then they say, bring down. Bring down the 8. And I want you to look at my face for a moment. Children look at teachers like this. And they plead, why? Why? And what do teachers say? Just do it. Now, why? And we are saying, just do it. And the children are innocent, you see. They don't know. And guess by the way, as I talk like this, talking this kind of talk, I walk around the room looking at them and say, don't you understand? Don't you understand? So what's the outcome of that? Don't you blame yourself? And don't you say, I'm not good at math. I'm not good at math. Okay, so then the untruths continue. Every statement you've heard so far is either untrue or meaningless. Every statement there is either untrue or meaningless. We must teach the ones created by the truth. We must teach them in truth, as I shall do now. Listen now to the difference between how teaching in truth compares with teaching through untruths and falsehoods. Okay, now we're going to verbalize this very differently. All right? Now, you know that this is a thousands place, right? This is a hundreds place, the tens place, the ones place. And what you're really doing here, what you're really called to do here is to subtract as many 4s from this number as you can. You see, there's a connection between division and repeated subtraction. Your teachers made the point, it's in the textbooks, they make the point that multiplication is repeated addition. But they fail to go to the logical extension of that, which is what? Division is repeated subtraction. They don't do that. They do only a piece of that. Every child should understand that if I subtract 4 once, in which case this number would be smaller, right? Then subtract another 4, and then another 4, and another 4. This number gets less and less and less, doesn't it? As I keep subtracting 4s. There will come a point, after a long while, when what's left is less than 4, won't it? And then I could get the answer by counting the number of 4s I subtract. I subtract 1, 4, 2, 4, 3, 4s. You know, eventually I get hundreds of 4s that I subtract. If I want to take that kind of time. Right? Children should know that. Right? But we're going to take shortcuts now. Because this represents 1,000 4s. This represents 100 4s, because that's a hundreds place, right? This is 10 4s, because that's a tens place. This is 1 4, since this is a ones place. Now 1,000 4s is equal to how much? 4,000, right? 1,000 times 4. So can you subtract 1,000 4s from this number? No, because 1,000 4s is 4,000, and that's too large. Everybody with me? Making sense? Okay, so I cannot subtract any thousands of 4s because even 1,000 4s is too large. And so if I cannot subtract any thousands of 4s, what shall I do? Subtract hundreds of 4. Now, you hear what you just did? That's like this child who is listening to the story, has picked up the trend and anticipated where it's going. That's what you just did. You just told me ahead of me where we're going. There is a great similarity between what your mind will experience as I do this and what your mind experiences as you hear a story. I'm going to make your mind function here in the same way that your mind functions when it hears a story. What's your mind doing as it hears a story? Your mind is clicking with understanding, right? The verbalization of a story makes it possible for your mind to click with understanding as a story is being told, right? Well, your mind will click with understanding as we verbalize long division now, right? So you know you cannot subtract any thousands of 4. So we're going to try to subtract hundreds of 4, right? Let's try 900 4s because 900 is the maximum, right? In the hundreds place, the highest you can go is 900, right? Well, you know that 9 times 4 is 36, right, everybody? So 900 4s is 3,600 or 3,600. Can you subtract 900 4s from this number? No. So what we're going to try now? 800 4s. Can you subtract 800 4s from this number? No. 700 4s. No. 600 4s. Yes. And 600 4s. Now, by the way, do you notice I'm speaking truth? You see I'm referring to this as 600. Before, when we did over here, I called it 6. So you see I'm speaking truth and writing truth. Speaking truth, writing truth. So I'm teaching in truth. And what's the value of 600 4s? 2,400. So I'm subtracting the value of 600 4s. Isn't that the value of 600 4s? Right? And what do we have left? 183. Does your mind click as I speak? Mm-hmm. That's the point. That's the point. That your mind can click as I speak mathematics, as I speak. Then you're functioning in the same way as your mind functions when it hears a story. You see what I'm talking about? The only mathematics program in the nation that has delivered long division, and I mean 6-place dividends and 3-place divisors. Second graders doing long division competently. This is a method. And so we've subtracted the maximum hundreds of 4. And so what should we try to do now? Subtract the maximum tens of 4. And the maximum in the tens place is 90. 94s, 360, too large, right? Can we subtract 84s? No. 74s? No. 54s? 44s? Yes. So we subtract 44s. Again, I speak truth and write truth. And 44s are 160. And so I'm subtracting the value of 44s from this, leaving 23, right? And from this we subtract 5 4s, right? Which is 20, and 3 is left. These methods, which deliver a lot of mathematics to children very easily, are so easy. That's a surprise. In mathematics, the truth also sets you free. They'll be free of fear. Your children are going to learn mathematics fearlessly, comfortably. That's what's going to happen here. The story of 9 plus 8. By the way, the word teen comes up in this story. And teen is a nickname for 10, right? So hold up teen fingers. Teen. So teen is a nickname for 10. That's what we'll tell your kindergartners, right? And then we're going to teach them to tell a story. The story of 9 plus 8 goes like this. 9 is sad. Oh, there he is. Okay. Here comes sad 9. He is sad because he wants to become a teen. You know by now that teen is another name for what number? 10. Do you see anybody could read what I'm reading and become a master teacher? Yes, teen is another name for the number 10. Well, if teen is another name for the number 10, how many more will 9 need if he wants to become a teen? 9 needs 1 more, right? Yes, 9 will need 1 more if he wants to become a teen. this is the story of 9 plus 5. 5 rushes up to 9. Read what 5 says to 9. Read 9's reply.
I'm sad because I want to be a teen.
Read 5's question.
9. How many more do you need to become a teen?
Read 9's reply.
I only need one more.
Read what 5 says to 9.
I have 5. I can give you one of mine.
So 5 gives 1 away, leaving 4. 9 gets 1. He becomes a teen. So 9 plus 5 equals 14. Right? Now, and so you're likely to hear your kindergartner one day, or your first grader, coming home to tell you the story of 9 plus 8, or 9 plus 6. It's a sad 9 story. Get ready. 9 is sad because he wants to be a teen. And 6 comes along and says to 9, why are you so sad? 9 says, I'm sad because I want to be a teen. And 6 says, well, how much you need to become a teen? 9 says, I just need one more. 6 says, well, I got 6. I can give you one of mine. And see, here is 6. 6 gives 9 one like this, and 5 is left. So 9 plus 6 is 15. Now, why do you think we want the child to tell the story? Because if you know the story, you're structured forever. You learn a story once and forever. The child who knows the story will retain it forever. Traditional mathematics education, there is no structure behind what you know. So when you want to know 9 plus 6, there's no thought like this. You just look up. It looks like you're thinking, but your mind is blank. Why? Because there's no structure behind what you know. So your child will tell you the story of 9 plus 8 and 9 plus 5 and so on. But what's the value of the story? Because once structured by a story, you're structured forever. So this program defeats remediation. You don't remediate stories, do you? You learn a story once and forever. It's exactly the same thing that will happen in mathematics, because structure will be the basis of everything they know, right? And so we will fulfill the potential in this program that the Lord intended, that all our children be excellent learners of mathematics. They're going to drink mathematics like milk, and you will be witnesses. I thank you for coming.